Hi everyone, welcome back. Um, in this video, I will follow up with the previous video. I was talking about the volume of a solid revolution using the shell method. And in my previous video, I was explaining about the concepts, how it formula derived from, and how to form a volume using revolving the region between one curve or two curves about the y-axis as well as the x-axis. So I show you the concept and I explain in details. Um, if you follow me to the full course and there is a connection from one lesson to another, you will be able to understand better because the way I develop my course, I connect one concept to another and a continuous. So if you just watching from YouTube, sometimes you might wander around like, I don't know what she was talking about because I put one after another. I'm not just doing one video, right? So it's the whole continuance of the sequence of the lesson. But anyway, therefore, I would like to remind you about my website of the course if you want to follow me to the full course. You will have two ways of doing it. One is mymathteaching.ca, key in Google, and you can learn weekly lesson for free online education. Um, and I post the course weekly in the order as well. So you can follow it in the order so you will have a better understanding um, of the concept and the connection of them. The second way, if you want to order the full time course, you will go to mathcourses-online.teachable.com. And I wrote it on the top of the board here. Anyway, I'm going to talk about the application of the volume of solid revolution. Follow up with the previous lesson. So I'm going to read out loud to you the question now and see how we apply the concept to solve it. The area under the enclosed by the curve y1 equal x to the power 1/3 or letter root of x and y2 equal x squared is rotated about the line x equal 2 to form a solid. Find the volume of the solid by using cylindrical shells. And let me give you a little bit of summary so that it's like we not jump in like in the middle, right? So in my previous video, we're talking about using the cylindrical shell to build volume. So this is the cylindrical shell, and the way we build, we form around, we rotate around the y-axis. So the shell method, um, if this method we revolving around the x-axis, then the shell method we revolving around the y-axis, right? We also can revolve around the x as well, but in that ways we will have to put the cylinder sideways like this, and we generate around the x-axis. And in that case, we will have to reverse the function. So in this question, I will just show you the way we do it without the reversing the function. We'll do the reverse later. So the idea is because we build the volume by the surface of the cylinder, not by the area of the bottom times with the height. So we're not talking about this method, which is pi r squared at the bottom. We're going to use the formula of the surface area of the cylinder, right? And the area of the surface of cylinder, you know that it equal 2 pi r, which is the circumference here, times with the height. And that is from the surface area, right? Not the volume. To form the volume, we have to time with the thickness of the shell here, which is so many layers we revolving around from here to here. The thickness of the cell, so after we have the surface area established, we multiply with so many layers here to form, multiply with the thickness of the shell, then we got the volume, right? And therefore, we have a formula here. So I put here dV. Now dV is the derivative of the volume, right? And you know that so far we have learned that the derivative of the area under the curve is the curve function itself, right? So the same like this in the volume. The derivative of the volume, right, equal 2 pi r, which is the formula to find the circumference of cylinder, 2 pi r times with the height of the cylinder. But because the height of our cylinder is changing, right, according to the function, so we substitute the height by the fx function here, time with the delta x, which is the thickness of the shell I just showed you, right? So that is the derivative formula. Now, to find the volume, we have to do integration, which is antiderivative of this function. So in the past, I have shown you, if we have one function, we do for one function here. But if we have a two curve, something like this picture, right? In my video, we have a h of x function, and we also have another function g of x. And we find the region between them we generate using the shell method. Then we will use the two function, right? We use the f of x minus the g of x. So one function here will become two function. So we taking the difference between these two functions and we integrate the interval from a to b. Now we also have a third formula here to find the volume using the shell method. And this volume equals the same exactly formula, except that the x here become the y, and the f of x become f of y, and the g of x become g of y. And this should be dy, sorry. It should be dy, right? And why it different and interchange instead of x, y? Because in this third formula, we're talking about generated revolving around the x-axis. So this formula for revolving about the x-axis, and that is the only difference. And that's why we have this third formula, right? If we're revolving about the x-axis instead of the y, for the shell method, we have to inverse this function. We have to reverse it. So f of x become f of y, g of x become g of y, dx become dy. That is the only thing we do, okay? So now let me get right into the question and how we do this. So I'm going to read this question out loud to you. The area under the enclosed by the curve y1 equal third root of x and y2 equal x squared is rotated about the line x equal 2 to form a solid. Find the volume of the solid by using cylindrical shells. So this is the question, and on my right board is the diagram. I draw it to show the diagram of this question, right? So let's take a look at my right board here. I sketch the y1 function. And the y1 function is the cubic, no, not the cubic, sorry, it's the third root of x, right? So this curve here is y1 and the third root of x. Or we can write x to the power, rational power 1 over 3, right? So this is the curve. Because any root function have a curve look like this. This is y equals square root of x. Now, if it's the third root, it will be low a little bit, but it's the same shape, right? So we know that. Now, the next shape, any parabola will have a shape like this, right? So I just draw half of the function here. This is the parabola, y equals x squared. This is a y2 function, y equals x squared, okay? And this is the curve of parabola, y equals x squared, this curve. We don't have to draw the half left, we just draw the half right, right? Okay. Now, we also know that these two functions intersect at the coordinate 1 and 1, because if 1 square is still 1. If you take the third root of 1, it's still 1, right? So therefore, they will have the same coordinate of x equals 1 and y equals 1. They intersect at this point. So I mark here 1 and the y coordinate here is 1. So 1 for x and 1 for y coordinate, right? They intersect here. So now, all what we have to do is realize what is the volume of the cylindrical shell here. I draw it, right? So keep in mind the radius of this shell, right? And let's just take a look from here to here instead of the whole picture. Now, you know that they will have a mirror, right? But when you fold it together, it will form a volume. But if you cut it open up, it's like two sides of mirror line in here. And we're going to rotate. These two functions form a region here, right? The same like this region. Now this one I shaded, this one I leave it blank because I want you to see the height here I draw. And the length of the x here I draw, I sketch. That's why I leave it blank. But it's supposed to be the region bounded by these two curves. And we're going to generate this region, rotate, right? And we form it by the many layers of the cylinder inside, right? One layer at a time, 3 layers, 4 layers. We will form these, rotate around the x equal 2, right? We'll rotate like that. And the thickness of the shell is on the way from here to here, right? Subtract whatever. So this is the thickness of delta x. The same like R2 minus R1. The radius on the way, subtract whatever the R1 here to form each thickness of the shell here. Each thickness of the shell here, right? So it go along with the way we generate it. So delta x here is equal R2 minus R1. The big radius, right? Subtract with the small radius. Okay. Now, I'm going to talk about, so now you look at this diagram, you have some idea about the way we sketch it. So first we sketch the y equal x squared, then sketch the y equal third root of x. We know they intersect at 1 for y and 1 for x coordinate. This is the point of intersection. And the way we generate, we're gonna form it the cylinder. We're gonna revolving, and we're gonna generate this layer, right, revolving around this x equal 2. That's the question they told us, right? Is rotated about the line x equal 2. So this is the central line of rotation, right? And this is the region we're going to generate it from inward to outward, right? As you can see that many shell of this cylinder here is the way you build this volume is from inward. So the first layer is about this, and then another layer. So it inward, right? Another layer, it form a thickness of the shell, and it become a volume of the object. Except this is the cylinder object. But keep in mind that the height of the cylinder is changing according to the function when we plug in there. So it will, the shell of the stacking of layer of this shell here will build the thickness for the volume. However, it's not really quite like a cylinder like I hold it in my hand. But if we substitute by the function, this object will shape under any form of any curve, right? And form a different objects, not just a cylinder like that. But the idea we're still using building the shell of the cylindrical shell to form the object, the volume of the object. And remember, the volume of our object is shaping by the curve, by the function. So then we will, after we generate and we build the thickness of the shell, we'll have an object like in this shape instead of the cylindrical, right? But let's talk about the way we're going to generate from inward to outward to build up the shell layer, right? We stack them together. We iterate from inward to outward. So what is the delta? So the width of our cylinder, right, is the radius. We call delta x. And the width of radius here equal, I mark here, because the thickness of this, right, is come from between this line, right, we generated from here to here. We generate this region only bounded by from 0 to 1, right? However, the radius of the cylinder here is the full length here, right, of our cylinder. Subtract whatever x as we go along. So this, if this x here up to here, then 2 units minus this x here to get the radius of the cylinder, right? And if our x is instead of here go up to here because according to our shape of the region, then add this x coordinate here is still like the 2 units subtract whatever x in here. 2 units subtract whatever x in here. 2 units subtract whatever x in here. And therefore it equal 2 minus x. That is our delta x, which is the radius of this cylinder, the wider, right, the length of the radius of the cylinder, which is R2 minus R1, and our R2 is actually up to here, which is 2 units, minus whatever the x as we go along, right? So we do that. So that delta x. So this delta x here is this one here, okay? Now, what about, so the radius of a cylinder is this. What about the height of the cylinder? The height of cylinder, right? Like this and like this and like this. The height of cylinder is also shaped by the height of the region, by these two curves here, right? And you can see that from here to here, this height. Now up to here, from here to here, this height. So the height of our cylinder here, as long as we build along, will be changing due to these two curves. So that we call the delta y. And delta y equal the height of our cylinder, which is equal y2 minus y1. And y2 is here, subtract y1 is here, right? Actually, y1 subtract y2 in this case, y1 minus y2, right? y1 is the bow curve, this curve, and y2 is this curve. So the y here is from the top curve, subtract the bottom curve. So that become a height. And this height is the subject of chain. And that's why we call the rate of change in calculus, right? So the height here is also changing according to the two curves here. So this here. Now we substitute in delta y will be equal, y1 is this curve, which is the root of x, minus y2 is this curve, which is x squared. So after we know the radius of the cylinder, right, which is delta x, like this, and the height of the cylinder, which is delta y, like this, we're going to form the volume now. So our volume, and actually we call it dV, right? Derivative of our volume, equal surface of the cylinder is 2 pi r formula time with the height of cylinder time with the thickness of delta x is the thickness of the shell, right? So this is represent many layer. We build it, right? Which is many laser, many shell, many cylindrical shell inside, right? To perform this thickness, okay? So now we'll substitute one by one. 2 still 2, pi still pi. The r here will be substituted by 2 minus x. So time with 2 minus x. The h here will be substituted by the height, the difference between these two curves, which is the root of x minus x squared. That's for the height here. And delta x is dx here, right? And if we add the integration in this dv, if we add this, we got the volume. Volume equal the integration of the derivative of volume and equal this. So we're going to generate this volume from 0 to 1, from inward to outward. Now keep in mind that I explained it on the previous video already for you, that when we generate this volume, right, we generate from inward to outward, and our rotation still follow the vertical line, right? But the layer of the cylindrical shell we will generate from 0 to 1, because this is the region we generated, right? This is the region we generated, right? So it from 0 to 1. So 0 to 1. And put this formula in, we have 2 pi times with 2 minus x times with the root of x minus x squared dx. Okay, and that is our answer for this question here. But how will we get the answer here, right? To get the answer here, this is the complicated function, right? This complicated function, you can multiply them together and simplify it before we do the integration, if we do it by hand, right? However, I would like to show you now today, I would like to show you the way we're going to do it by the calculator. But on the concept we learned in this topic, how we form, what kind of formula we use for cylindrical shell, how we stack this shell together like an onion, right, to form a volume, or the cylindrical here. But the shell, each cylindrical shell we generated, we build the thickness of it to form a volume, depend on the function, and that will shape our volume of the object according to whatever the function look like, right? It's a little bit complex, right? I don't know if the way I explain is appeals to you, but I try my best, right? I say that the height here will be delta y, changing according to the function. And each cylindrical shell here formed by building up the thickness, the surface of so many layers. But each layer here, instead of just the same size and the same shape like that, will be the layer of the object we're talking about. So our layer, the way we rotate this cylindrical shell and build the volume, will be shaped by the region of this. And you can see that true because the height of our cylinder here is a subject of changing due to this region, due to this height here. It tall here, but then it's shorter here, and then it's shorter here and shorter here, right? So the height of our cylinder was shaped by this two curve actually, right? Now this is the abstract concept. This is not the black and white. It's not like the fixed number, right? When we learn the just plug in the formula, plug in the number in our elementary, we learn. But this is calculus. This is the rate of change. So everything is in terms of the function we're talking about. So the height is also a function. The width of it is also the function. So the R here is the radius of our cylinder changing by R2 minus R1, as well as this X is changing, the R here of this cylinder is also changing as well. So all what we do is substitute by the function, right? And our unit of R is 2 minus X in this case. Now in another question might be 4 minus X or whatever, right? But that is the way of this question look like. So we find out the X, we find out the Y, and then we substitute in the formula, right? We find the derivative of the volume. We do antiderivative, we get the volume. Now I'm going to finish this question here by calculate this, right? I'm going to show you how we use the calculator to get the answer, because we can do by hand as well, but I show you so many times already by using hand. So now we're going to use a calculator, right? So it's like changing another, way of doing it. So on your calculator, when you do this, you will, when you do this, you will operate on the calculator, and the way you operate calculator, volume will become, the function will be F, I, and T stand for iteration. And then we put in, let me try this first, okay? So the way we do on calculator, we do like this. We do F, I, and T, open the bracket and open two bracket. 2 minus X time with the root of X minus X squared, and close the bracket, put a comma, put a X. X is just the notation we put in the program, show that, okay, we're going to generate from the X interval, right? And then 0 and 1, and close the bracket. And we get the answer. And don't forget, all of this have to time with 2 pi as well, right? Okay, so let's do this now. So on your calculator, I'm going to show you here, you will hit the math, turn it on first, right? You hit the math, and you see a bunch of numbers. So you will roll down to the number 9. And up to number 9, you will see this is F, and then N, actually Fn, I'm missing the N, right? It have an N here. So Fn represent the function. Int is represent the interval. So that's the name on the program, right? So number 9, I'm gonna hit there, enter it. So it show you that, right? Now I'm gonna open another bracket and I'm gonna put into minus x. That's the delta x, right? That x the thickness of the radius of the cylindrical shell, actually. So 2 minus x, close the bracket, open another bracket. I'm going to hit math so I can get the root, number 4, to get the third root, right? And I'm going to key in x and close the bracket and subtract, take away another function, which is x squared, and close the bracket and put the comma. Now, if these brackets are not operated correctly, you might get the error, right? So, comma, if you're just missing one bracket or missing a comma, it won't work, right? So, make sure it's got to be right. I'm not sure. So, I'm going to put an X here and say comma again, 0, generate from 0 to 1, so comma and 1, right? Close one bracket only. Now enter it. Going to generate it now. Yeah. So you can see that that's the number, right? If we key in correctly, exactly, not missing any bracket, like exactly like the way I wrote on the board, right? As long as you're missing one bracket or one comma, it won't work. So sometimes I found using the calculator, it takes longer and more complicated actually, but we should know all of this, right? Okay, so after we do this, we get this, we time with 2, we time this with 2 pi, 2 and pi, and enter it. The answer is 4.11399. So I'm going to round up, become 4.11 decimal place, 2 decimal place. So our volume equal 4.11 cubic unit. So that is the answer for this question. Okay. So I don't know, should I summarize the process again for you to see, right? I think I talked about this enough. So this is the way we're using the shell method. And you can see I draw the cylinder here, right? Between these two functions. So there's two functions. We draw the curve. They intersect from 0 to 1. And that's the region here. We generate, rotate it along, just like the y-axis. But we rotate, the center is x equal to this line, right? So we generate this region from inward to outward, like the way we build the shell layer one by one thickness, right, of this cylinder to form the volume. And this height of cylinder is delta y, is the height between these two functions, y2 minus y1. The width of our cylinder here is the radius, delta x. Delta x is from x equal to subtract wherever x go, right? So if x go up here, then this will subtract this to get the radius from here to here. If the x go up to here, then 2 subtract the x here to get the radius from here to here. So these are the subject of changing, right? So delta x equal r, 2 minus L1 equal 2 minus x. And delta y equal y1 minus y2, which is this function, subtract this function. So after we find the derivative of the volume like this, we build up the surface of cylinder like this, right? Each of the shell here is the surface of cylinder, right? And equal the 2 pi r on the top, the circumference multiplied with the width of the cylinder, but or the height of cylinder. But the height here is a subject of change according to the function. So the height here we call it delta y, and delta y is the two functions subtract each other, right? Make sure when you do this, you keep in mind that which one subtract which one lie above and which one lie below, right? So the above one subtract the below one. And we substitute in the iteration. We know that we generate from 0 to 1 because this is the region we do, right? This region like this one here, the middle line, and we generate from here to here, 0 to 1. So our iteration is from 0 to 1. Now, if we use a calculator, then that's the way we write. We key in and we get the answer here. So that's it for the video I am doing today. I hope that you will enjoy this video. You will enjoy this, and I hope you understand about what my teaching here. Now, if you watch the first video about the concept of the shell method I made, combined with this one, you might have a better understanding rather than just seeing this one. Okay, so I see you on my website. Get into my website and learn online course online. I'm done. Bye for now. Thanks for watching, and don't forget to hit subscribe and like if you like my video. Sorry. And again, if you're just curious, you want to know what calculus means, you can just hop in my website, right? mymarketing.ca, and you don't have to pay for anything, right? Watch the weekly online uh, free online education. So thank you for watching, and bye for now.